So in this video, I'm going to show how to apply both the show a biconditional and show a conjunction strategies. So we'll start off by showing the conclusion. We see we have a biconditional here. So the idea of this strategy that we're going to pursue is that if we can get these two sentences wrong rule, then we can infer the biconditional from them. If we have the two conditionals that make up this biconditional, we can infer the conditional, which gives us a direct derivation. Of course, we need to get these two, so that's what we're going to do. And fortunately, there's a show command, show cond for show conditional, that will write them in for us. So we're going to show one conditional first, and then we're going to show the other. And then we are going to put them together with the CB rule. Now we see we have a consequent here that we're trying, a conjunction in the consequence, so now we want to show a conjunction. Now if we do this, that's not very good, and the only way we really know how to use the negated conditional right now would be to do that, but that's just repeating line 6. Line 6 is just repeating line 4, so there's no point in doing that. So what we want to do instead is we want to show if we can get not Q, and we can also get R, then we can apply a junction to get not Q and R. So again, we're going to try to show those two things, do subderivations of both of them. And again, the program has a built-in show command for that. In this case, it's show conj for show conjunction. So we'll say show conj, let's choose Q. So now we'll make an indirect assumption. So let's see, we got two premises. Let's bring them in. Well, what can we do? 8 doesn't look very useful right now, but 7 might be. We can split 7 into two biconditionals. If we just write BC, it'll ask us which one we want. If we say BC and then the right R for right to left, or left to right, it will give us the component conditionals. So this splits up the two conditionals. And if we look, we can see, oh, with 9 and 6 we can do modus ponens, because the antecedent of 9 is Q, and that's what we have on line 6. And that's not P, and 3 is P, and so now we have an indirect derivation of not Q. Don't care about the insides anymore. Now we want to show the other conjunct, and then we'll adjoin them. So we're going to get not Q, and we'll say, okay, assume ID for Q. And this is going to go exactly the same way. We'll bring down that premise, and all we really want is the left to right biconditional. So we'll apply modus ponens, we get not P. Let's bring down R. We have an indirect derivation. Oh no! What did I do? I did the same thing. We need to show the other conjunct. Whoops! Here, we want to show R this time. Excuse me, I hope that wasn't too confusing. So now we'll assume not R. Much better. So we bring down premise 2, and we see we can do modus ponens with not R, and if not Q, then R. That gives us not Q. Now if we look at premise 1, we can see that we want the left to right biconditional, because if we remove the double negations from line 17, we can do modus ponens and get not P, and now we'll bring down R, and we have an indirect derivation. So we've shown both of the conjunctions, so now we're going to apply the rule adjunction, which puts the two conjunctions together, the two conjuncts, the two sentences it's applied to into a conjunction, not Q and R, and that's a direct derivation. So that's how you show a conjunction. You show first one conjunct, and then you separately show the other conjunct. So now we have got line 4, which is the consequent of line 2, so we'll box and cancel that way. Well, now we have one of the conditionals. Now we need to show the other one, right? Because we'll then apply CB to put them together. So we'll assume CD. Let's split these two up. And if we look up at the premises, we can see we don't need to show consequent, because if we look at premise 1 and we get the right to left biconditional, the right to left biconditional is if not P, then Q. And we can apply modus ponens, or excuse me, modus tollens with not P and Q, and not Q to give us not P, which gives us P, which is what we want for the conditional. So now we have both of the biconditionals. we put those together, we get the conditional, we have both of the conditionals, we put them together to create a biconditional, which is what we want. So just to review quickly, first we use these two show conditional commands to set up these two subderivations. They're completely independent of one another, they're just two different derivations. Inside here, the consequent of this conditional was this conjunction. So we said show the conjunction, and then we separately showed each conjunct. And to set that up, we use these two the show conj show command. So that's what we do to show a biconditional and a conjunction. Just these show conditionals, two separate subderivations for the biconditional, and then when it's a conjunction, it's two separate subderivations for the two conjuncts. And they will almost always be two separate subderivations. So if your conclusion is a biconditional, that means you're basically doing two derivations. You're doing a derivation of the conditional one way, and then separately the derivation of the conditional the other way. If you're doing a show conjunction, then again you're effectively doing two separate derivations. First you're doing a derivation of one conjunction, and then completely separately you're doing a derivation of the other conjunction. Okay, good. So that's what we do to show conjunctions and biconditionals.